Is this going to be over?
Because it's the pre-calculus class. You're taking a class before. Take a whole year of course before calculus just to prepare you for it. It's a prep course.
Why is this going to be the test?
On the final?
Yeah.
I think there's one problem with log condensing and separating. Yeah, I'm pretty sure there is. Okay? Again, trust me, Jason, you're going to see it's not a tough topic. We're going to get to the end and you're like, oh, that's all it is? It's just rules. You can do something like this, which I think everybody here can do this. You can also do this. Really? Come on. I hope you can do that. Gotta study a little more than if you can. So, what I want you to think about is this. In general, see how two things are being multiplied here? And they both have positive signs here? Over here in the second part, you have the n being divided. The n is being divided into the m. And look at the n part. The n part has a negative value in front of it. So what I wrote down is this general rule. Okay? In general, remember the following. With logs, when some value is in the numerator of the argument, put the plus sign in front of it. So here, these two values, m and n, they're in the numerator. They both have positive signs. In the next line, m is in the numerator, isn't it? And it's got a positive sign in front of it. N is in the denominator, and it's got a negative sign. This is much easier to remember what I'm telling you right now than it is to remember rules. All I think about when I do these is I break the whole thing up. Whatever's in the bottom, I put a negative sign in front of it. Whatever's in the top, I put a positive sign. Remember, they must be factors then. So I'm going to go into an example where that doesn't perfectly exist. Let's look at example 1. So we have expand 5x cubed over y with a log base of 6. So let's look at our rule. Our rule a minute ago told us that when there's a product, we write it as the sum. When there was a product, right here, we wrote it as a sum. Same thing here. So look at the numerator. What is the 5 doing to the x cubed? It's being multiplied, so that's called a product. So let's start by writing this as log 6 with a base of 5 plus log 6 as a base of x cubed. So again, those two quantities, 5 and x cubed, are both in the numerator. Since they're both in the numerator, they both have positive signs in front of them. What's in the denominator here? Just a y. So in the next part, put minus log base 6 of y. Again, it's much easier to remember what I'm telling you right now. Whatever's up top gets positive signs, whatever's down below gets a negative, and you just have to separate it by factors. What are factors again? Things that do what? Multiply. So for example, had the numerator been 5 plus x cubed, you cannot break it up like this. Since it's 5 times x cubed, you can. All right? Again, they have to be factors in one another. Now, to show you, remember how I said if there's an exponent, go back to the last rule, when there's an exponent, you can bring it down in front here. See how this exponent like kind of comes down right in front there, and that's what it looks like? To show you that, think of this right here as the following. And you don't have to write this if you don't want to, it's just the derivation. Think of this quantity as the log base 6 of x times x times x. Now, if I have three things multiplied, what can I write them as? Oh, I mean, I can write them as x cubed. Yeah, sorry. But I mean, if I use my rules, when I have a product, what did I make these?
5x.
What did I do? I added them. When I had a product here of 5x cubed, I added them together, right? So if you think of these as products, this is really the following. Log 6x plus log 6x plus log 6x. Do we see what I'm saying now? Remember when there was a product, you can write it as a sum? So this is really that. So this part is really that. This part is really that. Well, what do you get when you add the same thing 3 times? You get triple or 3 times that number. Very good. If I say x plus x plus x plus x, there are 4 x's there, right? So it's just 4x. So this is really saying log 6x plus log 6x plus log 6x. Well, that's just 3 log 6x. Well, take a look now. This right here is the same thing as just bringing this 3 out front. Again, this part right here is the same as just taking this 3 and moving it down in front. And that's where you get that from. Just to show you where it comes from. So if you were expanding this, your final answer is log 6 of 5 plus 3 log 6 of x minus log 6 of y. Okay? Again, that would be your answer for an expansion. This is useful. I know it seems like it's trivial right now. It's just a rule, but it is useful. We're going to do something with this. Yes, absolutely. We are going to do something with it. Yep. We're gonna be given some information at the determine stuff in a second. Okay. Again, break this up into its 3 components. How do I know there are 3 components in the end? How can I check? What's a mental check for this kind of problem? Look, there's one component or one term, a second term, a third term, right? These are all called terms. One term, second, third. How do I know there's 3 terms in my answer? What's a mental check? Not the exponent. I know that's tricky. That's a misleading thing because you see x cubed, and I understand that. Not plus or minus. Well done, Claudia. Very well done. Look at the argument, people. How many parts are there? 1, 2, 3 parts, or 3 factors in a sense. Okay. Again, the plus and minus comes from the top and the bottom. The 3 actually just moves in front. Okay? All right, let's take a look at the next one. So using the following, that log base 4, so imagine you have a calculator, okay? So when, I was in high school, not everybody had a calculator at all. This was only, not too long ago. I'm sure when Mr. Carter, when you were in high school, what did you guys use? Tables, right? Sine rules. Okay.
Log tables.
Log tables, yep. Just like you use sine, cosine tables, and trig tables.
What's that?
You have a book, okay? And in the book, it tells you all the logs. So if you want what the log of 10 is with a base of 2, you find that in the table. Log of 10 with a base of 3, you find that in the table, and so forth and so on. And you have those decimals. It was given like this, okay? So on the old exams, they used to not have calculators, so they would give you a quantity and say, given these 2, evaluate these, which looks tough. But if you just break them down by expanding, you'll see that you'll get all these values and you'll be able to plug them in. Okay? It's a good technique to know. It's not used widely today, but it's probably one of the best things I ever learned. And it really helped me understand the idea of substitution method. Okay, and I'm going to show you that right now. So what I'd like you to do, and what we're going to do, is evaluate all 3 of these expressions, A, B, and C. So first, how can I rewrite the first one, part A? Somebody give me the solution or rewrite it as an expansion. Separate it. Derek.
It would be log 4 base 3 minus log base 4 7.
Well done. Now, Derek, aren't you given those quantities in the beginning? Aren't you given log 4 of 3 right here? So isn't it just this 0.792? And on the right, isn't this just 1.404? So if you didn't have a calculator, you didn't know these logs, you would use substitution because you know this definition is given. This definition is also given. And then at this point, you could subtract that by hand if you needed to. Okay? You could also subtract it on a calculator. But again, we're presuming you didn't have one here. The solution would be negative 0.612. Okay? So all we're doing is separating so that we can utilize our definitions. Think about it. You're given a definition. It's a value, but it's really like a definition. I'm saying that, the log base 4 of 3 is 0.792. That's a definition, really. Okay, so these quantities that are defined up here are very useful to have. All right, that was part A. That was kind of the easier one, right? How about part B? How about part B? And good. Good. And then the other one? Well done. Why did you break it into 3 and 7? What is 3 times 7, Anthony? And you know 3 and 7, don't you? Take a look at what you're given up here. You're given 3, you're given 7. So Anthony said, well, I'm just going to rewrite this as log base 4 of 3 times 7. I'm going to think of 21 as 3 times 7 and split it up. Put the part with the 3 here, the part with the 7 over here. And at this point, we know those definitions. Substitute in again. We got 0.792 plus 1.404. Okay, yielding 2.196. Again, use your noggin, use your brain, guys. Okay, you have to critically think about some of this stuff. You can't just say, it's just going to jump out at me. Anthony noticed 21 is 7 by 3, so clearly he was able to break it up. Last one, part C, log base 4 of 49. Any ideas for this one? Ashley? Very good. So hold on. actually is breaking it up either way. You can break it up like this, whoops, of 7 by 7 like that, right? And then break that into log 7 with a 4 plus log 7 with a 4. What's the alternate way to do this, Luis? Good, because what can you break up the 49 into instead of 7 times 7? How would you write it? 7 squared, and then the 2 comes down front. Yes, you can do it either way. Again, either solution is acceptable here, guys. These are two alternate solutions you're seeing. So if you notice that this is 7 by 7, you think there's 2 of them, you can write it as 2 log 7. But you could also write this as 7 squared and just bring down the 2 in front. Okay? And then again, log base 4 of 7 was defined as 1404 plus 1404, which is just going to give us 2808. Okay? 2808. Same as answer you would get on the right-hand side, because you would just do double that number. All right, let's go on to the third example. Evaluate the following expressions using the change of base rules. Using the change of base rules. Now, for a problem like this, for part A, what can I first start by breaking this into here? How can I break up the 5, 6? What should I write part A as? We just did this a minute ago. Good. Log 3 base 5 minus log 3 base 6. But now I just want to reiterate the fact that, remember yesterday, you can't actually get those answers on a calculator. You have to use what we said, the change of bases. You remember from yesterday what to do? For this one, how would you evaluate log base 3 of 5? Anybody remember from yesterday? Over. Very good. You write it as log 5 over log 3. You don't need to capitalize it. I'm capitalizing that because on your calculator, that's all you need to do. Press log 5 over log 3 there. Okay, but you do not need to capitalize it. Okay, so you can just write this as log 6 over log 3. Okay? Now, be careful here, people. Be very careful. This 5 over 3 here cannot be divided. This 6 over 3 cannot be divided. Okay, that's a common mistake. You need to simply evaluate in your calculator. You need to type in log of 5 divided by log of 3, enter. Minus log of 6 over log of 3. Make sure you put parentheses if you're going to do this all in one line. If you're doing the whole thing in one line, put parentheses around your quotients, please. Even though they're not really needed in this problem, it is useful to remember. Okay? So let's see what we end up getting here. We have negative 0.166. Okay, so check your answer, please. Make sure you get the same thing. Again, I'm assuming you're doing this in your calculator. How could I have also, just for a little side note, not that it's really that important, but take a look here at this point. How else could I have written this once I see I have this line right here? What do you see both fractions have? The same one?
Denominator.
Denominator. So I could have written this, if I wanted to, as log 5 minus log 6 all over log 3. I could have written it as log 5 minus log 6 all over log 3. Okay, that's another way I could have written this problem. Any questions on this? Okay, that's part A. Part B, log base 12 of 3 times 4. So, before we even begin this problem, what do you notice right away? Anybody pick up on something?
Did they both equal 12?
Yeah, they're both 12, aren't they? Right, so isn't this really log base 12 of 12? And what did we say from yesterday? If the base and the argument are the same, what does a log always equal to? 1. So the answer is just 1, clearly. Okay? But I want to prove that real quick to you. But again, the answer is definitely 1. So think of this as log base 12 of 3 plus log base 12 of 4. Is that clear? The product is written as a sum, just like we've been doing the whole time. Now, at this point in time, what I can do is think of this as log 3 over log 12 plus log 4 over log 12. And if you want to type this in your calculator and see what you get, you're going to get 1. Okay? Again, because this is really log 12 of 12, which is always 1. Okay, that was our rule from yesterday. Okay. Again, either way is appropriate, but I'm just showing you the beginning where this comes from. Okay, you can separate it. You'll still get 1 as your answer there. All right, let's take a quick look at example 4. This is a good example. If any of you guys want to take next year, which is something you really should, I highly encourage you to do this. There are SAT subject tests. And you've probably heard about these from your teacher, maybe, maybe not. And the way it works is you take a test on a subject specifically. So if you're really good at chemistry, you should probably take the SAT chemistry test. And it's out of 800 points, that's it. There's an SAT math test, in addition to the one you take normally the SAT, that's just math. And there's a level 1 worth 800 and a level 2 worth 800. These are the kind of problems you will see. Okay, these multiple choice problems that are this difficult. So get used to this idea. It's a good thing to do. If next year you take, what are you guys taking for AP Social Studies, US History?
Yeah.
You can also take the SAT US History subject test. Because trust me, if you take the AP exam in that class, you'll probably score in the 700s on the SAT too. It's such an easier test compared to the AP exam. Okay? So I recommend you do that. This is the kind of problem you'll see. All right. Which of the following is equivalent to the 3 logs you see there? Now, you see 3 logs, and what do you only see here? How many logs? Each choice?
1.
Just 1. So instead of expanding now, what are we doing? Putting them together, which is called what? Condensing. Condensing. Okay, or putting them together, or simplifying, or whatever other word you want to use there. Jay?
Like, so when it's like log 2 is positive, and then
Good. This is a positive, first thing to notice, and this one has a...
negative.
So where are we going to put them based on that fact?
Like, I'm just asking, like, with the division side.
We're going backwards now. Remember last time we had multiplication and division, and we became plus and minus? Now we got to go from plus and minus back to multiplication and division. Okay? Now, before I do that, though, everybody see there's a 3 coefficient here? And what should I do with that 3 coefficient? Make it an exponent. Very good. I saw you hand there. So we got log 9 in the front, and we should put plus log of 2 to the 3rd here, minus log 3. Okay, again, take this 3 that you see in the front, move it up as an exponent. What do you get? What's 2 to the 3rd, everybody? Isn't it just 8? So this is log 8. So I'm just going to rewrite it like that. All right, so I got log 9 plus log 8 minus log 3. Again, I got log 9 plus log 8 minus log 3. When there's a plus, where did it come from? The numerator or the denominator? And the minus came from the? So just write one fraction, please. And put whatever is with a plus up top and whatever has a minus down below. Okay, plus up top, minus down below. What's 9 times 8? 72 over 3. What is it? Oh, 24. Thank you. I thought you said something else. 24. Again, how's an easy way to cancel this 2? There's a 9 and a 3. Put a 3 there. 3 times 8 is 24. Okay? So instead of expanding, we're just condensing here. That's it. Only major difference is that we are condensing. Any questions on that one? Any questions? Okay. We're going to keep on going. We're going to get tougher and tougher. Next part. Earlier, we were given the definition of a log with a number. We were told like log base 4 of 3 was equal to 0.792. Log base 4 of 7 was equal to 1.404. Now, instead of that, though, instead of given a numerical value, we are given a variable expression. So take a look here. We want to find the following. In terms of, it should say in terms of, sorry, in terms of A, B, and C. So add that, please. In terms of A, B, and C. Okay, A, B, and C. So part A. Before we begin part A, what do I have? Do I have 2 things being multiplied or divided? Part A. Divided, right? So what does division mean again? Subtract. So let's write this as log x squared minus log y. What do I do with that 2 for the x squared? Yeah, put it in front of the log. So I got 2 log x minus log y. Well, I can't go any further, right? So I'm done. Why am I not done? Yeah, it says in terms of A, B, and C, and we see x's and y's. So based on our definition, what can I write, Anthony, as the answer here? Be careful. Not 2 log base of A.
Oh, can I do it? Can I do it?
Oh, yeah, my base four.
Two,
Give him one more shot. Give him one more shot, and then I'll let you go, Jay.
is it 2A minus B?
Very good. Because remember, log x is defined as A. So replace log x with A. Log y is defined as B. So replace log y with B, and this is your answer in terms of A and B. Another good SAT type problem where you'll have multiple choice, and the answers will be like 2A minus B, 2 log A minus log B. Maybe A squared minus B, because they forget to bring the square up front. So this is a good multiple choice kind of problem. Okay? Let's do part B together now. Part B, we got log z over x squared y. Somebody tell me what to do with this part now. Juliet? Minus 2 log x? Thank you. Be careful if you're going to do all at once. Go ahead. Minus log y. Where is it, Juliet? Good. In the denominator, apply the negative sign. It makes it so much easier. Again, the x squared is in the bottom. Instead of putting x squared here, what did Juliet already do? She took the 2 and brought it out front. Remember, there was really a 2 here. This was really x squared. She took that 2 and already moved it down in front. Okay, just to do it all in one step, which I would absolutely agree with. Okay?
So, even though they're being multiplied with the denominator, still put it on.
Because, you know what, really, you know how you would really write this? You would write this as log z minus parentheses log x squared plus log y. But if you have a minus outside the parentheses, doesn't the minus get distributed anyway? That's why that doesn't matter. Okay? Good point to notice there, please. So, we know log z, what was it defined as? C. Log z was defined as C. So we put a C here. Log x was defined as A. How many of those do we have?
2.
We have 2 A's, and then we have 1 B at the end there. C minus 2A minus B is your final answer. Okay? Alright, we're doing well, guys. Last one. So, there's a little blurb about inverse functions. And this is what I actually talked about a little while ago when I said that these operations are similar because they're inverse functions. Okay? So, the log and the inverse function, log and the exponential function are inverses. That's what it starts to say. So then it says simplify the following expressions. Okay, let's take a look at part A before we get into this example. So here we've got, I'm going to write a little bit bigger, 10 to the log of 4. Now, if you don't see a base, what is the base really? It's 10. Remember that from yesterday. It's not 1. Be careful. So there's really a 10 right here. Everybody see that? There's really a blue 10 there. Or whatever. Now, look at your rules. Look at your rules that you see up here. You're told that b to the log b of x is just x. See this rule up here on the right? And now take a look at what we've got. Isn't that what we've got here? Instead of having a b, though, what do we have? A 10. And instead of having an x, what do we have? A 4. So this whole thing is just simply equal to what? 4. Again, when you raise a power to a log of the same base, those kind of cancel. I think of this as canceling each other out. Because the exponential and the log are inverses of each other. You know how, remember, sine inverse and sine kind of cancel? Last night when you were doing the trig packet, when you wanted to find the angle C, you had sine of C equals, you did the sine inverse to get rid of the sine. It's the same idea. This is the inverse of each other, really. So these kind of cancel out. It doesn't really, but I want you to just think about it like that. Okay? Part B now. Part B, we have log base 5 of 25 to the x. Log base 5 of 25 to the x. I'm going to write this one down here. Now, if I wanted to simplify this, what can I do with the x? What? Put it in the front. Very good. So start with putting it in the front. But I really can't go any further just yet, can I? There's not much more I can do just yet. But what can I break up 25 into? What's the common thing? 5 and 5, right? So let's go ahead and do that. Let's think of this as x times log base 5 of 5 times, log base 5 of 5 times 5. Now, if I want to continue this process, when I have a multiplication, what do I think of that as? Addition, right? Addition. So I write this as x times log base 5 of 5 plus log base 5 of 5. Why did I just put parentheses around that? Somebody explain that to me. That could be a little confusing. Yes, x, take a look at the beginning, guys. Go back to here. X is a factor, and log 5 of 5 times 5 is a factor. So there's really parentheses around these, even though you don't see them. And if I'm going to break up something that's in a parentheses, the parentheses needs to remain. Now, let's go quickly back up and look at our rule, though, again. Our rule told us here that if we have log of the same base and the same argument, what happens to this? What does it just become? It kind of cancels out to be x, yeah, because look, this x comes in front, right? This x becomes x log b of b. But what's the log b of b always? What is it? It's 1. Be careful. Earlier we talked about when the base and the argument are the same, it's just really 1. So this becomes x times 1, or just x. So now just look back here. This is really just 1. This is really just 1. What's 1 plus 1? So it's just 2x, or x times 2, or just simply 2x. Okay? It's just 2x here. Now, the last way you could think about this as an alternate solution, just so you're all clear, here's what I would do in my head sometimes. Take a look back at the original right here, please. And I'm going to put an alternate solution. Think of this as log base 5 of 5 squared to the x. Log base 5 of 5 squared to the x, which to me is really log base 5 of 5 to the 2x. Remember, when you raise a power to a power, you have to multiply those powers. Well, look. There's that 2x that we have, right, as an answer? The log base 5 of 5 kind of cancels itself out. That's the rule here. That's what we just showed a minute ago. Log base b of b with an x just remains x. So whatever the exponent is really the answer there. So really, these kind of cancel each other out, and you're left with 2x. So the solution could just be 2 steps, or it could be a few more steps to get the same answer of 2x. Okay? Remember, guys, tomorrow, 1 o'clock, review session. Today after school, 3:30 to 5, review session. I'm giving you a homework worksheet. I trust that you'll do it. Again, you're not having a quiz on this. Okay, so it's up to you to decide to do it, but I hope you will. Today, 3:30 to 5. Tomorrow, 1 o'clock on. Bring lunch if you want to. Okay, bring some stuff. We can do till whenever. Yeah. Monday also till whenever. Okay?
I'm gonna stay here till 8 and 9.
If you want to come to the Nationals game and you want to buy a ticket, remember they're $10. We have 24 tickets for June 20th at 7 p.m. First 24, okay, first 24 to buy them, that's all I have. I can't get any more. Again, guys, I'll see you today after school or tomorrow. I hope I see everybody. It's not goodbye because I should see all of you for review. Okay, today, tomorrow, or on Monday. I'll be in here on Saturday also. Okay? If you want on Saturday, I'll put it on that night. Probably from 10 to 12 on Saturday. Okay? Yes. Everybody got a homework? Are there any extras? Any extras?
Yeah, they are.
No, they can't even bother.